Hello everyone, welcome back to this data science series. In this lecture, we are going to cover upon logistic regression. Like what is logistic regression? We have talked about linear model, this general linear model. It is a more advanced form of this. So let's get introduced to logistic regression. It is has classification, like it is a statistical model used to predict the probability of binary outcome, typically represented as 0 or 1, and it has a sigmoid function which employs or which maps any input value to a probability between 0 and 1. These are the key characteristics of logistic regression. It has distribution, link function, and its model form is this. Distribution is it assumes a dependent variable follows a Bernoulli distribution. Like Bernoulli distribution is being followed by a dependent variable. Here dependent variable is log p by log 1 minus p, and link function uses the log function, logit function p equals to log p1 minus p, where p is the probability of the event occurring, which we have discussed. It can be 0 or 1 in the binary form. In the model form of is this is log of p by 1 minus p equals to beta 0 plus beta 1 into x1 plus beta 2 into x2, where x1 and x2 are the independent variables and log p by 1 minus p is dependent variable. Now let's have a look on assumptions of logistic regression. First one is linearity. As we have discussed that it is the advanced form of general linear models. So where he have linearity, which is relationship between predictor variables and the categorical target. And then we have independence. The observation should be independent of each other, and there should be absence of multicollinearity, which we have recently discussed in the previous video of dimension reduction. Now let's have a look on advantages and limitations of logistic regression. In advantages, we have easy to interpret and understand, and but there is a limitation of it, that linear relationship between predictors and outcome can be less accurate than more complex models, like we have discussed the multiple regression model, which is not a linear model. Then let's have a look on the code of this logistic regression. This is the code of logistic regression. Here we have imported those packages, we have loaded this ARIS data, split the data into training and testing sets, initializing by using the logistic regression function. Then we have trained the data, then we have made predictions on the test data set, and then calculated the accuracy, because performance matrices are important to be used. So this is the output which we get, that the accuracy is 1. Now let's have a look on another model which we use here, which is Poisson model. But before that, let's interpret the logistic regression results, which has coefficients and odds ratios, and then we have performance matrices. Here in the code we have used accuracy as the performance model, accuracy, precision, recall, and F1 score, which we have discussed in previous videos. And this is about Poisson regression model, and key characteristics of this are distribution, which assumes a dependent variable, follows a Poisson distribution, and in the previous one we have followed the Bernoulli's distribution. Here we have link function, which uses the log natural algorithm, and that in previous one we have used logit uh, function, and its model form is log mu a Greek variable, beta is equals to beta 0 plus beta 1 into x1 plus beta 2 x2, and so on, where x1 and x2 are independent variables, and log mu can be a dependent variable. Mu is expected count of the dependent variable. Okay, so let's have a look on the code of Poisson regression using Python. Here we have imported the packages which we will need in this code. To perform the Poisson regression method, it is used for modeling count data, and here we have simulated the count data. I've mistaken, sorry. Simulated the count data, then we have prepared the data, and we have then fitted it in a Poisson regression model using GLM function, and then we have got the model summary. This is what our output looks like in as summary. So we have performed the Poisson model regression. Now let's get back to our lecture, which is comparison of logistic and Poisson regression, because we have learned so far about logistic and Poisson regression. And here we can see that logistic regression predicts the probability of a binary outcome in 0 or 1, whereas in Poisson regression it counts the data with a Poisson distribution. So it has a wider approach. That is it for today's lecture. I hope you have learned about this models, and in the next video we'll learn about association rules. Thank you for watching this video.